Hi everyone, welcome to Learning Math with VK. Today we explore lesson 27 in algebra, exponential and logarithmic functions. Number one, exponential function. An exponential function has the form fx equal b to the x, where b is the base, it is more than 0, and b is not equal to 1. X here, as you see, x can be any number. I mean, the domain here is everything. Negative infinity to infinity. The range here is, well, because b is more than 0, we can only get positive number as output. So range is from 0 to infinity. Let's take a look at a graph. Let's say example, graph fx equal to 2 to the x, y is equal to 2 to the x, right? And then we have the point x, y, -2, so 2 to -2 is 1/4, -2 and 1/4, -1, 2 to -1 is 1/2, -1, 1/2, 0, 2 to the power 0 is 1, 0, 1, 1, 2 to the power 1 is 2, 1, 2, 2, 2 square is 4, 2, 4. X, Y. -2 and 1/4. -1, -2. 1, so 1/4 is, I'm going to cut this out into 4 parts here. So 1/4 is right here. -1 and a half, halfway, so it's going to be right here. 0 and 1. 1 and 2. 2 and 4. Somewhere up here. This is the shape of the graph. So what if we want to graph 2 to the negative x? Example. Gx is 2 to the negative x here. What is going on here is that the output will be the reverse of the output of fx equal 2 to the x. So the graph of gx here, it would reflect over the y-axis, reverse output, so reflect over the y-axis. Reflect. And ta-da! This would be the graph of gx. And Pretty cool, huh? Also notice that 2 to the negative x can be written as 2 to the negative 1 times x. So this would be 2 to the negative 1 to the power x, and 2 to the negative 1 is 1 over 2 to the power x. Well, as you can see, if the exponent is negative or the base b is less than 1, then we have an exponential decay, and this is called an exponential decay. And then for the base to be more than 1, we call this exponential growth. I'm going to write on the graph here. One more thing, the base can be e because the base is more than 0, different from 1. So if base equal e, then fx equal e to the x is the natural exponential function. Now let us move on to the logarithmic function. Okay. In order to study logarithmic function, we first take a look at the exponential function. So this is an exponential function. Fx is b to the x. And as you can see, it has one input for every output. One input, one output. So this is a one-to-one function here. If it's a one-to-one function, of course, they're going to have an inverse. And the inverse is going to be a reflection over the line y equals x. Do the reflection. If you do the reflection correctly, then it's 1. So it's the number 1 right here. The graph is going to go this way. Okay. So this is the graph of the inverse of the exponential function, and we call it the logarithmic function. And it is defined to be f inverse of x which is log base b of x, the logarithmic function. Or the inverse of an exponential function. B will stay the same because this is the base. B is greater than 0 and B is different from 1. Here you can see the domain of log is the range of the exponential function. So domain is from 0 to infinity. And then the range here is negative infinity to infinity. One thing very important, that is the relation between the logarithmic function and the exponential function. We call that the inverse property. What it says here is y equal log base b of x is equivalent to x equal b to the y. We're going to use the inverse property to define property of logarithm in the next section. Thank you for watching. I hope you find the content useful. Please like and subscribe to help the channel grow. See you in the next video.